Good afternoon, everyone. Uh, let's start today's session. Uh, so we have more than 10 students who have logged in. Okay, let's start today's session. Once again, can someone confirm that they can hear me clearly on your microphone? Anyone, please? Just say yes. Okay, thank you. So I'm going to start today's session. Uh, can you see my screen? Can someone confirm?
Yes, sir.
Okay, thank you very much. I'm going to start today's session. Before that, let me switch off my camera. So, hold on. Okay, now let's start today's session. In case I go off or you can't hear me, don't worry, I'll be back. Now, today we'll be learning again something new. We'll be learning about the concept of modular programming or functions. Okay. Uh, you see this virtual car. This car runs on code. Uh, it's got millions of lines of code, and it's a virtual car. Now, the whole idea is to make you realize that code can be complex, can consist of millions of lines of code. F-35 is a new dogfight uh, with over Chinese and Russian stealth fighter advances. Okay, this is an Australian fighter by Australian Air Force. Apparently, it went into controversy because it had got some lines of code problem. Okay, some code issues. Okay, you might have heard a few last year itself how Boeing ran into trouble because of its one of its signature aircraft had got coding issues. Okay, so coding can be very complicated, my dear students. So managing code is very important. If you look at Android, okay, Android operating system, which runs on your phones, those of you who are having Android systems, 12 million lines of code, 3 million lines of XML, 2.8 million lines of C, 2.1 million lines of Java, and 1.75 million lines of C++. So having so many lines of code, managing them is not easy. So there should be a way to modularize code, okay? To put code in special boxes, in special cabinets, so that you can manage them. So that's what we're going to learn today, okay? We're going to learn more about the concept of modularization, the concept of functions, okay? So let's start today's session. We'll be learning about the structure of a simple and complex program, and we'll look at some of the built-in and user-created functions. Built-in functions are the system functions, and user-created functions are functions which we as a programmer, as a user, create. Okay. So what is a simple program? Program with only one function is called a simple program. And which is that function, my dear students? That function is the main function. Without the main function, we don't have a C program, correct? A complex program, on the other hand, consists of main function along with other functions. Remember I told you, if you have got a huge number of codes, instead of dumping them all into one function, aka main function, it would be better to divide them into different functions, also known as user-defined functions. So having multiple functions is known as modular programming. Okay, so each function can be called a module. Now, the built-in function, also known as system functions. When the C programming language was created, a lot of inbuilt functions were programmed inside a library. For example, main function is a system function. Okay, all those mathematics function are system function. Print line is a system function, and so on. We also have user-defined function, which is also user-created function, which we as a programmer can create so that we can put our code effectively inside them. Each user-defined function can be a box where we store our code. Now look at this simple program. This is a simple C program, which is a very structured program. Program always starts with the main method, goes inside the code. Code means open curly brace, close curly brace, goes and executes the first line until it reaches the last line. Starts with line number one and ends with line number 7 until it exits the program. This is known as a structured programming language. Okay, a simple structured programming language. Now, moving on. In this structured programming language, now I have complicated it by adding another function. You see, now we have got two functions in this program. I have the main function, also known as the main method, the main function, also another function. Now, look at the code. The compiler goes to the main function, line number 1, and then executes all the other lines until it comes to the end. When it comes to the end, you see, I'm calling another function. The moment I call another function, from here, it jumps and goes to another function. From here, it jumps and executes another function. Comes here and shows you on the screen, tired. Now, let's say I add another line of code, main. So when I call another function, it comes to another function, shows you tired, and then guess what? I'm calling the main function. So from here, it goes back to the main function. Again, it executes the main function, calls another function, goes to another function, executes this, calls the main function, goes to main function. So what I have effectively created over here is an infinite loop without using any loop. Okay, my dear students, this is like a virus. This will create a infinite loop. Now, moving on. A structured programming language, okay? Short, simple programs that we have created by using only one function, which is our main method, okay? Now, what happens when your code becomes too complex? You cannot dump all your code inside the main method. You'll go crazy. You cannot do that. Now, think about this. Windows XP, an old operating system. Before Windows 10 even came into existence, we had Windows XP, which had 50 million lines of code. Can you imagine 50 million lines of code? Can you imagine them dumping it all on the main method without any other functions? Of course not. There must be thousands of functions inside the Windows XP operating system. What about Boeing 787 Dreamliner? 6.5 million lines of code. Okay. Now, the Boeing company last year had been running into a lot of trouble after the air crash investigation, which said that the problem was with the software. Okay. So just imagine the software developer who developed their software must be getting many sleepless nights. Okay. What about S-Class Mercedes-Benz? 20 million lines of code for its audio and navigational control. What about Google? Single monolithic repository model supporting Google Docs. 2 billion lines of code. Definitely, you need to branch them into functions so that your program will make sense. Okay, this is important because when you do your assignment, you will have different sections in your assignment. You also have to put it in different functions. Okay, if you do not put it in different functions, then you will risk software failures like what happened to Boeing. Okay. Now, I'm not saying what happened to Boeing was because they didn't use enough functions. What I'm saying is that it would be easier to modularize your code and maintain it if it is divided into functions. Then you can isolate and find your errors easily. So, what we do to make our management of code easier, we break up the code, modularize the code, okay, into functions, into methods, into procedures. And I'm using different names: module, function, procedure, method. There is a slight difference between these, but you don't have to know that. If you're a computing student, you will know more about this. But as engineering students, just think of them as the same thing. Okay. Now, you already use functions in your program. Uh, for example, printf is a system function. Scanf is a system function, also known as built-in functions. Okay. Now, if you look at the code of printf, it has got 19 lines of code, but you don't see that because it's in the library. It's in when you install Dev C++, it is already in your system. The library has got printf with 19 lines of code. Now just imagine if you do not use stdio.h, the moment you don't use this library file, it doesn't know what is printf. Then you have to type all the 19 lines of code in order to just show something on the screen. Okay? So that's why we use our header files. Now, every time in a program, we mention our library file, std input output, standard library input output.h. So it goes to this header files and it looks information for all the functions that you're going to use. Okay. So in a general C program, you have got your header files or any other file, and then below it, you have your functions. Definitely your main function. Now, I have a question. Can we have a C program without the main function? Is it possible? Anyone? Anyone? Can anyone say yes or no, please?
No.
Okay, a program which executes cannot exist without the main function. But if you're creating a DLL or a library program, it can exist without the main function. So the answer is, my dear students, yes, you can have a program without the main function, but that function cannot be the main program. It cannot be the exe file, okay? It can only be a support file, a library file. Okay? Moving on. Now, if this is a simple program, look at a complex program. How many functions do we have in this program? 1, 2, 3. Okay, we have got 3 functions. Now, look over here. Main function is a system function. The program cannot exist without it. Besides the main function, I have created 2 user-defined functions, function 1 and function 2. Okay, now, before you use the function, you have to declare the function, also known as prototyping the function. Declare the function. If you don't declare it, your compiler will give you an error. Your compiler will say, hey, what is this? Hey, what is this? So you have to declare your function. Either declare it or make sure your main function is right at the bottom. Okay, we'll talk more about this later. Now, look at this program. Main function, okay, and another function known as vec. How many functions I have? 1, 2. Remember, if you want to use a function, you have to first declare it, okay? Void vec. That means the vec function does not have the return keyword, is not returning anything. Int main, because it's returning 0. Over here, 0 means exit success. Okay? Since it's an integer return, you have to say int main. Since no return keyword, void. Okay? So what happens in this program? Compiler goes to the main function. Once again, I repeat, before you use the function, you have to first declare it, prototype it. Now that you have declared it, the compiler is okay with that. It goes to the main function. You call the vec function. Remember, the compiler always looks for the main function first. Once it finds the main function, it goes to the first line until it reaches the last line. Now, in the first line of the main function, we are calling the vec function. So from here, it jumps to vec. Here, you're creating an array called vector. Size is 3, consisting of 3 subscripts, 0, 1, 2. And then another variable I. So the 0 subscript is 44.4. The 1 subscript is 45.4. The 2 subscript is 46.3. Now, using a for loop, I'm going to show the values inside. That's it. Okay. Now, what I can do, I can change this program to make sure that I do not do prototyping. I do not do function declaration. All I have to do is remove the function declaration, take my main function, and put it down here after the vague function. There. Put it down. That's it. Now, you do not need to do function prototyping. You do not need to declare your function. As long as you put your main function, which is the calling function, at the end of the program. Okay? The calling function should always come after the called function. Then you don't need to do function prototyping or function declaration. Okay? Remember that. So you can do it in this way as well. Now, there is another thing you should realize, that the variables that we have inside our program have a scope, have a range. They can be a local variable or a global variable. When a variable is inside a function, it can only be used in that function. Then it's a local variable. If a variable is outside, if you declare the variable just below the header files and it's not inside a function, then it's a global variable. It can be used everywhere in your program. Okay? For example, look over here. How many functions do I have in this program? 2. One is vec, the other one is main. Okay? Now, look over here. No need for function prototyping. No need for function declaration. Function prototyping and function declaration is the same term. Okay? So, no need to declare the function. Why? Because my calling function main comes after vec, the call function. So in this case, no need to declare. Okay. Now I've declared a variable integer I. I is a variable which is a local variable. See, I is inside the vec function. Vec function opens here and ends here. An I variable can only be used inside the vec function. Main will not know anything about the I variable. If you say, if you want to, for example, print fi over here, the compiler will tell you, hey, what is I? You say, hey, I is right over here, but wait a second, I belongs to vec. It's a local variable. Main doesn't know that it exists. Okay? So remember, when you create a variable inside a function, can only be used inside that function. If you want to make sure that main uses it and vec also uses it, then you make it global. Instead of declaring it here, you declare it outside these functions. Now, you see, I just limited the scope of I by declaring I inside the for loop. When I declare I inside the for loop, it can only be used in the for loop. It cannot even be used outside the for loop. Now, I scope has been limited. In order to broaden the limit of I and make it usable by all the function, you can make it global by declaring it here, like this. Once you declare it here, now I can be used by vec. I also can be used by the main method. Okay? So a global variable can be used by all functions in the program. Now, just as you declare variables in your program, just as you declare constants in your program, okay, you have to also declare functions before you use them. Okay? Unless you make sure that the calling function, which is usually the main function, is at the bottom. Supplied functions, okay? Supplied functions means system functions, like the main function, like the mathematics function, okay? Before you use them, sometimes you have to mention that that you want to use them in the header file. Okay, for example, if you're using any of these supplied, also known as system functions, mathematics system function, then you have to use the header file #include math.h. And in Linux, if you are compiling it, you have to say /lm. If you're compiling in Linux only. In Dev C++, no worries. Okay? But you have to use the header file math.h whenever you use these system functions. If you want to know more about this system function, you can go to the Linux man pages and you can know any information you want. For example, information about the power function. Power means 2 to the power of 3. Power 3, 6. That means 3 to the power of 6, which is 729. We also have the rand function. You can know more about how the rand function works to create a random number and how the time function works. How do you combine the random function and the time function to generate unique numbers. Like if you're creating a program which is a gambling application, then you will need to generate a dice or a die. Okay. In those cases, you have to use the random and the time function together. Okay. Now, standard input and output function, you have to always use the header file stdio.h. And the standard input and output functions are printf and scanf. Input, scanf. Output, printf. Okay? Now, after 2 weeks, we'll learn more about reading and writing. So we'll learn about fopen, fclose, fscanf, fprintf. Okay? For now, remember, stdio.h is the library file which has got information about your printf and scanf system functions. Okay? Now, we also have certain string system function. Supplied function means system functions. These are string copy, string concatenate, and string compare. String copy copies from the second variable to the first variable. String concatenate joins the second variable to the first variable. String compare compares the first variable with the second variable, the values. If the values are the same, it returns a value which is 0. If values are not similar, it either returns a positive or negative value. Okay. For example, I'm creating a variable, array variable val consisting of 30 subscripts. Now, I say string copy, val, and the string easy lesson. So what happens? Easy lesson is going to be copied from here to the val variable. So the value of val is going to be easy lesson. String concatenate, for example, val value is easy lesson. Now it will have, you see there's a space before it starts. Space, it is not, will be added to easy lesson. So what is the value of val now? Easy lesson, space, it is not. Another example, let's say I create 2 arrays, val1, val2. This one is feet, this one is feet. Okay? Now the pronunciation is the same, but the meanings are different. Now I use string compare, comparing the first value with the second value. Since they are not the same, the value of n may be a positive integer or a negative integer. We don't care. If they are the same, then the value returned by string compare will be 0. The value of n will be 0. Once the value of n is 0, we know that, hey, these two values are same. But in this case, they are not the same. Now, using a supplied function, a system function, for example, in this case, what I do is I use the math header file. Why? Because I'm using the power function. Okay. So what does this program do? If you look at it, I have a loop starting from I value 1 and ending with 20, less than or equal to 20. So the loop will continue how many times? 20 times. And every time it goes in, it shows me the square of the value. Okay? It shows me the square of the value. Now, if you look at this example, I have got only one function, main function. Okay? If you look, in this case, I have divided into 2 functions, main function and my underscore pow function. So every time it goes inside the loop, sq is equal to my underscore pow. So the moment you come here, it goes to this function, passes the value of I to x, passes the value of 2 to y. One of you, please switch off your microphone because it's disturbing. Now, next, the result will be square of 1 is, it will show the squares of 1 to 20. So you can either do it in this way with two separate functions or with one function. Okay. Now this program is small, so putting it in one function, main function, makes sense. But let's say if you're doing your assignment, which is going to be perhaps more sophisticated, it won't make sense to put it all in one main function. You might have to divide it into different functions. There. Look at this program. There is no function declaration. Why? Because the calling function, main function, comes after the call function. But what if I want to put the main function first? Like in this case, you see, then I have to do my function declaration. Okay. Now, every function, my dear students, has got a name, has got a return type. We say return type is float. Why do we write here float? Because return temp. Temp value is float. So when you are returning, this cannot be void. It has to take the value of the variable you are returning. Temp is a float data type. So here return type should be float. So every function has got a return type, and every function has got arguments, also known as parameters. For example, my underscore pow function has got two parameters, x and y. X is float, y is integer. So you can declare variables inside parameters, inside arguments of a function. And whenever you declare it, you also have to mention it, how many parameters and what data type they are. Okay. Let's do a quick tracing on this. How many functions I have in this program? Two, my underscore pow and main function. Okay. No function declaration. Why? Because the main function comes only after the calling function my pow. So I don't need to do function declaration. So let's do a tracing. Main function, variable I, float sq for I is equal to 1, I is less than or equal to 20, 1 to 20. So this loop will continue 20 times. Okay. So every time it goes inside the loop, I call my underscore pow. So it goes and calls the function my underscore pow. So it goes over here, passes the value of I to x. What is the first value of I? 1. 1 will be passed to x and 2 will be passed to y. So here 1 will be passed to x and 2 will be passed to y. Okay. Next, another variable I. Okay, float temp is equal to 1.0, and then you calculate the value of temp and then you return temp. Temp is float. So the return type for my pow should be float. So the value will be returned back and stored inside the SQ variable. And then you show the value inside your SQ. Printf, the value 1 will be shown. Then again the loop will increment. 1 will become 2. So next, again you call my pow. This was 1, now it is 2. So the 2 value will be passed to x. X will be 2, and this 2 value will be passed to y. Again, it will calculate the value of temp. Okay, this time, what will be returned? 4, because the square of 2 is 4. 4 will be returned and will be the value of SQ, and then you show it on the screen. So that's how this program will work. My dear students, remember what I told you before the MCO, before the lockdown, when we had the lecture? If you want to learn programming, do tracing, like what I'm doing over here. That is the best way you can learn programming. Okay? I can also do this program by taking my pow function after the main function. If I do that, I have to do function declaration. Now, if I run this program as it is, the compiler will give me an error. The compiler will say, hey, what is my underscore pow? Why? Because I've not declared it. So you have to declare the function right over here. Once you declare it, now the program will work without any issue. Okay. So as I told you before, every function has got a return type and it has got parameters. Parameters are also known as arguments. Okay. Like this example, my function return type is float. Why? Because it's returning a float data type. If you don't use the keyword return, then this will be void. This my underscore pow function has got two parameters, two arguments. One is float data type, one is integer data type. Okay. So just remember, every function has got a return type and parameters. Okay. Now we are going to go to another concept in programming, which is passing variables. You can pass variables from one function to another function, just like the previous example. Look, what did you do over here? You passed a variable from here, from my pow function to main function. Temp value is passed and stored inside SQ. Okay, return. Since it's a float value, you have to say return type is float. The value is returned, okay, and stored inside SQ. Okay, so there are two ways you can return a value or pass variables. One is passed by value. For example, in this case, I have a function. Look, from the main function, I'm calling foo underscore one. Okay. This is not this. This doesn't spell fool. Please do not misunderstand. It's foo underscore one. So you're calling foo underscore one function. So goes over here, passes the value of k to j. So k is a variable belonging to main. J is a variable belonging to foo underscore one. Remember, they are local variables. Local variables cannot be shared. Only the value of k is passed to j. Let's do a tracing so we understand this better. Look at my program. I'm going to do a tracing. Now, how many functions do I have in this program? Foo, one, and the main function. Okay. Now, look over here, two functions. I didn't do function declaration. Why? Because my main function, the calling function, comes after the foo1 function. So, no need to declare it. Okay. Now, where does the compiler go? The compiler always looks for the main function. In the first line, I'm creating a variable k and I'm giving it a value 10. Okay, giving the value 10. I also, in the foo1 function, I created a variable j and initialize it to 0. Now it won't initialize yet because I haven't called the function yet. Remember, the compiler always comes here first. Okay, k is initialized to 10. Next, printf. On the screen, imagine this is my computer screen. I'm doing a tracing over here, my dear students, so that you also can learn to do this when you go through the code on a piece of paper. Remember, tracing is your friend. Tracing will make you learn programming. Okay? So next, printf, initial value of k is 10. So on the screen, k value will be 10, and then backslash n means go to a new line. Initial value of k is 10. Next line, I call the foo1 function. So from here, the compiler will jump to this place. It will pass the value of k to j. What's the value of k? 10. 10 value will be passed to j. So there it is. J value will also become 10. right over here. The moment it goes inside the code, J value is changed to 0. J value will be changed to 0. And after that, it comes to the end of foo1 function. And then it goes back to the next line of code from where it came from. Comes here, printf. Value of k after applying foo1 function is equal to, what's the value of k? Still 10. So the value of k after applying foo function is equal to 10. And then the program is over. Now, this is an example of call by value. In call by value, both the variables have no relationship with each other. Only the value is passed. For example, here, k belongs to main. J belongs to foo1. No relationship. But the value of k, which is 10, is passed to j. Just the value. This is call by value. We also have call by reference. Now, in call by value, remember k and j have no relationship, separate variables. In call by reference, we make them join. We make them have a relationship. We bind them in a marriage with each other. Okay? Here, no marriage, separate. Here, there is a marriage. They are linked to each other. Now, how do we create that link? The same program, now you can see slight difference. The foo1 function, I use the indirection operator before j. And when I call the foo1 function from the main function, I put the ampersand sign before k. Now, what is this indirection operator, which we call? What is the meaning of this asterisk before the variable? And what is the meaning of this ampersand before k? Now, this is not AND logical operator. Please do not misunderstand. The AND logical operator consists of two ampersand. Single ampersand means it is the reference operator, also known as address of. Indirection operator here means value of. So what I'm doing here, I'm saying, hey, the address of k is going to be linked to the value of j. In other words, k variable and j variable are going to be married to each other forever and ever till death do us part. Okay? There's going to be a marriage between these two. Let's do a quick tracing. Again, what happens over here? We have got two functions, foo1 and main function. The compiler always goes to the main function. Int k is equal to 10. So the value of k becomes 10. Okay. Next, printf. Initial value of k value is 10. So on the screen we'll see initial value of k is 10. Next, I'm calling the foo1 function. So from here, it jumps here. It passes the value of k, the value of k is 10, okay, to j. But we are not just passing a value. We are saying, hey, I want you to, you see, ampersand sign means address of. I want you to link the address of the variable k with the value of j. Okay, so these two are going to be binded together. The value of 10 will be passed to j, as well as both of them will be joined together. Address of k will be joined to the value of j. Now, since they are joined together, whatever happens to j happens to k as well. Look, once it goes here, j is equal to 0. The moment you change j to 0, guess what happens? K value also changes to 0. This is call by reference. These two variables are linked together. After that, it comes back to the next line of code. We were over here. It comes back to the next line of code. Okay. Printf, value of k after applying foo1 function is k. What's the new value of k? 0. So on the screen, you will get 0. This is call by reference. Just remember, call by value, the two variables have no relationship with each other. Call by reference, the two variables are linked to each other. So knowing this, you can decide which one to implement in your program. Do you want the variables to be having association with each other? Then use call by reference. Do you want the variables not to be related to each other? Then use call by value. Okay. Now, usually when you use printf function, it uses call by value, and scanf uses call by reference. That is why whenever you use scanf, you use the address of, you use the reference symbol. Remember, my dear students, whenever you use scanf, you use ampersand. Okay. Another point, when you use pass by value, for example, the value 128 will be passed to a function. But whenever you use pass by reference, the memory address of 2 will be passed to the function. So that is why the memory address and the value of the two variables will be linked. So in call by reference, there will be a link, a sort of a marriage between the two variables. I have another program over here. Let's do a tracing for this. Okay. Look at these two programs. Okay. This is passed by value. This is passed by reference. Now, both these programs, look, in this place, there are two functions, main and swap function. Okay. I'm doing function declaration. Why? Because my calling method, main method, comes before the call function. So I have to do function declaration. If I don't need to do function declaration, just take the main function and put it at the bottom. Now, look at this. Let's do a tracing on this. Let's look at the left program first. In the left program, it's called by value. I declare two variables, a and b. A is 2, b is 1. Then I call the swap function. Swap function is here. So the compiler jumps to this place, passes the value of a, which is 2, b, which is 1, to x and y. So the value of x becomes 2, the value of y becomes 1. Then, using a third variable inside the swap function, I swap the values. I swap the value. See, temp is equal to x is equal to y is equal to temp. So I change the value of x to 1 and y to 2. I swap the values with the help of a third variable. Okay? That's it. And then what happens in this case? It is called by value. A and b will be 2 and 1, but x and y will be 1 and 2. Okay? Very straightforward. No relationship between the two variables. But look at pass by reference. I do the same thing. Okay? I do the same thing. 2 and 1. A value is 2. B value is 1. When I call the swap function, the values will be passed to x and y. 2 will be passed to x and b value will be passed to y. B value in this case is 1. Okay. Now, since the values are passed, remember, this is called by reference. So we are saying address of A is linked to the value of X. Address of B is linked to the value of Y. So using the same temp variable as before, I swap the value of 2 and 1. So X value will become 1 and Y value will become 2. I swap the values. But since they are related, they are linked to each other, the moment I change X value to 1, guess what happens? The value of A changes to 1. The moment I change Y value to 2, the value of B also changes to 2. Okay? Because in call by reference, the variables are joined together, linked with each other. This is pass by value and pass by reference, my dear students. Now, again, remember, in a program, you have got local variables and global variables. Local variables can only be used in a function, not outside the function. And global variables, you declare it outside any function so that all the functions can use them. Okay. Look, over here, I have pi function, sorry, pi variable, not function, pi variable, which can be used in the main function. It can also be used in the function called function. Okay. But if I declare the pi variable only inside main, it will only be used inside main, cannot be used inside any other function. But if you make it global, all the functions can use it. Now, if we look back at the bisection method, which we studied during loops, in bisection method, if you remember, it's a law in mathematics. We find the root of an equation given the function, okay? So using iteration, what we do, we keep on bisecting and finding the midpoint, okay? Finding the midpoint, and we keep on until we reach a value which is greater than 0. Okay, so this loop will continue. Now, the same program like before, but what we do over here, every time, instead of writing it in this way, okay, what we do whenever we calculate our f underscore left value and f underscore midpoint value, we can give a value by putting the code inside a root function like over here. You see in the root function, okay, it calculates and returns the value to f underscore left. Again, using the same function, returns the value to f underscore mid value. And then using that, you can find out, hey, is it greater than 0? If this is true, it will execute this. Else, it will execute this. Okay. This is implementing function inside our bisection method. So today we discussed program structure for simple and complex programs, and we studied about system functions and user-defined functions. Okay. Next, you do your lab session. Mr. Suresh will take care of you for your lab, where you will implement your functions. Okay. Now, my dear students, I hope all of you are doing your, let me come back to this. Hold on. Okay. I hope you are doing your assignment, because you may think that you have a lot of time, exactly 1 month until your submission of assignment, but it's very important for you to do little bit every day. Okay. So please get started on your assignment if you have not started already. Okay. Whatever you have studied earlier, please implement it according to the requirement of your assignment. And also remember what I told you. Please do your assignment in isolation. Do not be influenced by the code of your peers or your friends, else you will get into trouble. Okay, you don't want to get into trouble. Not now, my dear students. Assignment is worth 60%, which is very substantial. Okay, so my dear students, please do not get into trouble, and ensure that you do your assignment properly. Get started today itself. Just go with the main method, main function, and the variable. Get started. Get your hands dirty. Okay? Because you can ill afford to push it to to 1 week before the submission day. This is not an assignment. This is not a difficult thing to do. It's an open book, but it's not something that you can finish in 1 or 2 nights. Okay? You have to think. You have to test. You have to uh, you have to do tracing. Okay, my dear students. So please get busy and do this properly. Okay. Anyone has any questions? So we have got more than 20 students today. Okay. Anyone has any questions? If not, then we close today's session. 4 minutes left to 3. So I finished early. Okay. My dear students, I'm going to record this. I've already recorded this video. And what I'll be doing is I will be uploading it to Moodle as well. Okay, so please go through the video in case you want to go through the sessions. And if you have any questions, you can either ask Mr. Suresh or myself. Okay, wishing you all the best. Okay, thank you very much for your attention. I'll see you all next week. Okay, please stay safe and take care of yourselves. Okay, my dear students, thank you very much and see you. Bye.